What if the first person to travel between dimensions isn't some distant future explorer, but someone who's already walked among us? Picture a world where the boundaries of reality aren't as solid as they seem, where hidden dimensions could be just a ripple away, waiting for the right mind, the right moment to cross over. This isn't science fiction. It's a possibility that some of the brightest scientific minds are taking seriously, and today we're diving into 30 mind-bending theories that could rewrite everything we know about the universe's first interdimensional traveler. Think about the stories woven into ancient myths and modern-day encounters, accounts of people vanishing into thin air, glimpsing worlds that shouldn't exist, or returning with knowledge no one could explain. Could these be more than just legends? Could they be fragments of truth scattered across time, hinting at something far more extraordinary? The idea of interdimensional travel isn't just a wild fantasy. It's rooted in cutting-edge physics, from string theory to quantum mechanics, where the fabric of reality might be far more fluid than we ever imagined. So, what if the first leap between dimensions already happened? What if the clues are hiding in plain sight, in forgotten experiments, unexplained phenomena, or even in the quirks of history itself? Over the course of this journey, we'll uncover theories that range from the eerily plausible to the edges of the unbelievable. Some will challenge your understanding of time and space. Others might make you question whether we're truly alone, or if we're just one layer of existence among countless others. Strap in, because we're about to explore the unexplored, and by the end, you might never look at reality the same way again. The Nazca lines stretch across the Peruvian desert like a giant sketchbook, massive, intricate designs that can only be fully appreciated from high above. How could an ancient civilization create such precise formations without the ability to fly? Some researchers suggest these aren't just art, but landing markers or messages meant for beings who didn't view our world the same way we do. This is the heart of the ancient astronaut hypothesis, the idea that advanced travelers from other dimensions might have visited Earth long before recorded history, leaving behind clues in our myths, artifacts, and even our DNA. Take the Sumerian texts, for instance. These ancient tablets describe the Anunnaki, godlike beings who supposedly descended from the heavens with knowledge far beyond human understanding. They spoke of flying machines, celestial weapons, and even genetic manipulation. Could these stories be garbled accounts of interdimensional visitors? Some theorists argue that these beings didn't just come from another planet, but from a parallel reality, using technology that allowed them to slip between dimensions as easily as we step through a doorway. Then there's the mystery of the Antikythera mechanism, an ancient Greek device so complex it's often called the world's first analog computer. Its gears and dials could predict astronomical events with startling accuracy centuries before such technology should have existed. Was it the product of human ingenuity alone, or could it have been inspired by, or even borrowed from, travelers who understood the fabric of reality in ways we're only beginning to grasp? Modern physics offers tantalizing possibilities. String theory suggests our universe might be one of many, stacked like pages in a book. If higher dimensional beings exist, their perception of time and space would be fundamentally different from ours. To them, moving between dimensions might be as simple as turning a corner, a feat that would seem like magic or divinity to ancient observers. The artifacts and legends we've inherited could be fragments of their visits, misunderstood over millennia but pointing to a truth far stranger than fiction. So were the Nazca lines a runway for interdimensional craft? Were the Anunnaki not gods but explorers from a realm beyond our own? The ancient astronaut hypothesis forces us to reconsider the boundaries of history and reality itself. If even a fraction of these theories hold weight, the first interdimensional travelers might not be a future discovery, but a forgotten chapter of our past. The Ark of the Covenant isn't just a relic of biblical legend. It's been described as something far stranger. Ancient texts claim it emitted lethal energy, vaporized those who touched it improperly, and even guided armies to victory. But what if its power wasn't divine but dimensional? Some theorists propose the Ark wasn't merely a sacred chest, but a device capable of bending space-time. Its construction, detailed with precise materials like gold and acacia wood, eerily parallels modern concepts of conductive elements used in high-energy experiments. Could the presence of God said to dwell within it have been a stabilization field, keeping an unstable interdimensional gateway in check? Then there's the enigma of Egyptian hieroglyphs. Among the usual depictions of gods and pharaohs, carvings at the Temple of Seti show what appear to be helicopters and spacecraft. Mainstream archaeology dismisses these as eroded symbols or coincidental patterns. But another interpretation exists, that they're literal records of advanced technology witnessed by ancient priests. If interdimensional travelers visited Egypt, might they have arrived in vessels that, to untrained eyes, resembled flying machines? The hieroglyphs could be attempts to document the incomprehensible, like a caveman sketching a smartphone. Even more intriguing is the legend of the Door of the Gods at Hayumaca in Peru. Locals speak of a massive stone doorway carved into rock where shamans once vanished, returning with visions of celestial realms. Modern researchers note the structure's uncanny resemblance to a stargate-like portal, complete with a keyhole depression where, according to lore, a small golden disc could activate it. No such disc has ever been found, but the story persists, a tantalizing hint that certain artifacts might have been designed as controls for dimensional passage. What ties these objects together? Across cultures, they're described as conduits to the divine, radiating power beyond human understanding. But in the language of theoretical physics, their traits align disturbingly well with speculative interdimensional tech: sudden energy discharges, spatial distortions, and even localized time anomalies. Whether by accident or design, ancient civilizations might have interacted with devices they didn't fully comprehend, tools left behind by visitors who moved through reality as effortlessly as we navigate a hallway. The question isn't just whether these artifacts were portals, but who or what was using them. Quantum entanglement is one of the strangest phenomena in physics, a phenomenon so bizarre that even Einstein called it spooky action at a distance. When two particles become entangled, their states are linked no matter how far apart they are. Change one, and the other instantly changes too, defying our traditional understanding of space and time. But what if this eerie connection isn't just happening within our universe? Some scientists speculate that entangled particles could be acting as living bridges between dimensions, their instantaneous communication skipping not just across vast distances but between realities entirely. Take the famous double-slit experiment, where a single particle behaves as both a wave and a particle depending on whether it's observed. The mere act of measurement seems to collapse its possibilities into a single outcome, a concept known as the observer effect. But some interpretations suggest that unobserved versions of the particle don't just disappear. Instead, they might branch off into parallel dimensions, continuing to exist in realities that split away from our own. If that's true, then every quantum event could be a doorway, with entangled particles serving as anchor points between these branching worlds. Experiments in quantum tunneling add another layer to this puzzle. Particles sometimes teleport through barriers they shouldn't be able to cross, almost as if they momentarily slip out of our dimension and reappear on the other side. Could this be evidence of particles briefly accessing higher dimensional space, where the barrier doesn't exist in the same way? The mathematics behind string theory supports this idea, proposing that extra dimensions curled up too small for us to perceive could allow particles to take shortcuts through reality itself. And then there's the notion of quantum foam, a seething, fluctuating fabric at the smallest scales of spacetime. Some physicists theorize that within this chaos, microscopic wormholes constantly form and dissolve, connecting distant points or even different dimensions for fleeting instants. If entanglement creates stable links across these wormholes, it might be possible to exploit them, using quantum systems as maps or gateways into other layers of existence. So if entangled particles are already whispering across dimensions without breaking any cosmic rules, could conscious travelers one day follow? It's a staggering thought that the first interdimensional journey might not require a massive machine or a rip in space-time, but simply the right understanding of the quantum threads already woven through reality. The bridge might not be something we build, but something we've finally learned to see. Black holes have long been imagined as the ultimate cosmic dead ends, regions of space so dense that not even light can escape their grasp. But what if their true nature is the opposite? What if these terrifying voids aren't endpoints at all, but gateways? A growing number of physicists now suspect that black holes might be bridges to other dimensions, their unimaginable gravity warping space-time so severely that it opens passages to realms beyond our own. Consider Hawking radiation, the phenomenon where black holes slowly lose energy and evaporate over time. Stephen Hawking's groundbreaking work showed that these cosmic giants aren't entirely black, they emit particles, albeit at a glacial pace. But where does the information swallowed by a black hole go? The holographic principle offers a startling answer. It might not vanish, but instead be encoded on the black hole's event horizon like a cosmic hard drive. This suggests that everything falling into a black hole could be preserved in a two-dimensional imprint, only to re-emerge elsewhere, perhaps in another universe entirely. Then there's the ER equals EPR conjecture, a daring idea that links two seemingly unrelated concepts in physics. Einstein-Rosen bridges theoretical tunnels through space-time, often called wormholes, might be connected to quantum entanglement, where particles remain mysteriously linked across vast distances. If correct, this would mean black holes aren't just isolated traps but entangled with something on the other side. Falling into one could, in theory, eject you into a distant region of space or even another dimension. Imagine diving into a black hole. The tidal forces would stretch you apart in a process called spaghettification, but some models suggest that a sufficiently large black hole might spare you from instant destruction. Instead, you could pass through a chaotic yet navigable wormhole, emerging in a reality with different physical laws or a universe where time flows backward. The mathematics even allows for the possibility of white holes, the hypothetical exits of these tunnels, spewing out matter instead of consuming it. Could this explain certain cosmic anomalies? Some quasars, extremely bright galactic cores, emit energy in patterns that defy conventional explanations. Might they be the white holes of our universe, the exhaust pipes of interdimensional travel? If black holes truly are portals, then the first interdimensional travelers might not need advanced technology at all. They'd just need to survive the plunge. Ever noticed how so many people vividly remember Nelson Mandela dying in prison during the 1980s despite clear historical records showing he lived until 2013? Or how an unsettling number insists the children's books were spelled Berenstein Bears with an E, not Berenstain with an A. These aren't just quirks of faulty memory. They're examples of the Mandela Effect, a phenomenon where large groups share identical false recollections of events that never happened. But what if these glitches in our collective consciousness aren't mistakes at all? What if they're echoes bleeding through from alternate realities? The concept hinges on one of quantum physics' most radical ideas, the many worlds interpretation. Every time a decision is made, the universe might split into multiple branches, each containing a different outcome. In one reality, you turned left at the intersection. In another, you went right. Most of these parallel worlds remain forever out of reach, but what if the barriers between them aren't perfectly sealed? Tiny cracks could let fragments slip through, residues of events from neighboring dimensions imprinting on our minds as phantom memories. Take the infamous fruit of the loom logo debate. Thousands swear the brand's label once featured a cornucopia behind the fruit, though no such design ever existed. Could this shared hallucination be a glimpse into a timeline where the logo did include that basket? Or consider how people recall movie quotes like, "Luke, I am your father," with absolute certainty, despite Darth Vader never actually using Luke's name in that scene. These discrepancies cluster around specific, emotionally charged cultural touchstones, exactly the kind of moments where realities might momentarily overlap, leaving traces in our mind. Skeptics dismiss the Mandela Effect as confirmation bias or the brain's tendency to fill gaps with familiar patterns. But quantum biologists propose something wilder. Our brains might be biological receivers tuned to multiple frequencies of reality. Under rare conditions, perhaps during states of high stress, déjà vu, or even cosmic events like solar flares, this tuning could drift, picking up faint signals from adjacent dimensions. It wouldn't require full-blown interdimensional travel, just a fleeting resonance, like catching a radio station from another country through static. The implications are staggering. If memories can leak between worlds, could information or even consciousness cross over too? Reports of sudden, unexplained skills like waking up fluent in a language never studied, or prophetic dreams describing places that later match reality down to the smallest detail might be more than coincidence. They could be glimpses of lives lived in other versions of existence. The Mandela Effect might not just be evidence of parallel worlds, it could be proof we're unwitting participants in a multiverse far more interconnected than we ever imagined. Deep in the Amazon rainforest, shamans brew a potent drink called ayahuasca, a sacred tea that propels drinkers into realms beyond ordinary perception. At the heart of this brew lies DMT, a molecule so powerful it's been dubbed the spirit molecule. Those who have experienced its effects describe vivid encounters with intricate geometric worlds, sentient entities, and landscapes that defy physics. But are these visions mere hallucinations, or could they be windows into dimensions our waking minds can't normally access? Indigenous cultures have used DMT-containing plants for centuries, treating these journeys as sacred voyages to spiritual planes. The Shipibo people of Peru, for example, speak of Icaros healing songs learned directly from plant spirits during ceremonies. Modern users report eerily similar experiences, independent of cultural background, floating through fractal cities, communicating with beings who insist they're more real than real, and returning with impossible knowledge. The consistency of these accounts raises a haunting question. If these worlds were purely imaginary, why do so many encounter the same landscapes, the same guides? Science offers startling clues. DMT occurs naturally in the human brain, released in tiny amounts during birth, death, and near-death experiences. Some researchers propose it acts as a reality tuner, temporarily shifting our perception to perceive hidden layers of existence. Dr. Rick Strassman's groundbreaking DMT studies in the 1990s documented test subjects who insisted they'd visited parallel dimensions, often describing them with uncanny similarity despite having no prior knowledge of psychedelic lore. One participant even claimed to have met aliens who showed him a DNA structure he later found matched cutting-edge scientific models. The debate hinges on consciousness itself. Traditional neuroscience dismisses these experiences as neurotransmitter fireworks, the brain misfiring under chemical overload. But the holographic theory of reality suggests something more profound. That DMT might temporarily dissolve the filters our brains use to construct consensus reality, allowing us to perceive the raw source code of existence. In this view, shamans aren't just hallucinating, they're skilled travelers navigating a multiverse that's always present, just normally invisible. Then there's the entity phenomenon. Over 80% of high-dose DMT users report encounters with intelligent beings, machine elves, mantis creatures, or ancestral guides. These entities often behave like conscious inhabitants of their realms, teaching complex concepts or performing surgeries on users' spiritual bodies. Could they be projections of our subconscious, or might they represent life forms native to dimensions we're normally blind to? The answer might lie in quantum biology. Some theorists propose that microtubules in brain cells could function as quantum antennas, and DMT might enhance their ability to receive information from beyond our spacetime. Whether chemical key or cosmic radio, DMT challenges everything we assume about reality's boundaries. If even a fraction of these experiences reflect actual dimensions, then the first interdimensional travelers might not need spaceships. They might simply brew a tea, close their eyes, and step through the membrane separating worlds. The most ancient portals could be hidden in plain sight, inside our own biochemistry, waiting to be unlocked. The story begins with a warship vanishing in plain sight. According to urban legend, in October 1943, the United States Navy conducted a secret experiment off the Philadelphia Naval Shipyard, attempting to render the USS Eldridge invisible to radar using powerful electromagnetic fields. But something went terribly wrong. Witnesses claimed the ship didn't just disappear from radar screens, it physically blinked out of existence, teleporting to Norfolk, Virginia, before reappearing moments later with several crew members fused into the bulkheads or driven insane. Some reports even suggested sailors phased in and out of visibility, caught between dimensions before vanishing forever. Declassified naval records tell a different story. The Office of Naval Research has repeatedly denied any such experiment took place, stating the Eldridge's logs place it in New York during the alleged event. But conspiracy theorists point to gaps in documentation and the Navy's heavy redactions of certain wartime projects as evidence of a cover-up. The truth likely lies somewhere between myth and military secrecy. The Navy was researching degaussing techniques to make ships magnetically invisible to minds, a far cry from teleportation, but enough to spark rumors among sailors already steeped in wartime paranoia. The Philadelphia experiment's enduring appeal stems from its collision with genuine science. Einstein's unified field theory, which sought to merge electromagnetism and gravity, was still fresh in scientific circles. While never proven, the theory speculated that manipulating these forces could warp spacetime, echoing the Eldridge's alleged disappearance. Even more intriguing are the testimonies of Carl Allen, better known as Carlos Allende, whose letters to astronomer Morris Jessup detailed the experiment with unsettling precision. Allen claimed to have witnessed the event from a nearby merchant ship, describing sailors freezing mid-step or burning with an eerie blue glow. Skeptics dismiss him as a fabulist, but his accounts of electromagnetic bubbles distorting reality bear uncanny resemblance to modern plasma stealth technology. Then there's the human cost. Whether real or myth, the stories of crew members suffering from nausea, radiation like burns, or psychological breakdowns mirror documented effects of early radar and high-energy experiments. In the decades since, researchers have confirmed that intense electromagnetic fields can induce hallucinations, suggesting the sailors might have experienced collective perceptual distortions rather than interdimensional travel. But alternative physicists propose another explanation. The experiment could have inadvertently created a localized spacetime vortex, briefly puncturing the fabric of reality before snapping shut, a phenomenon not unlike theoretical wormholes. So was the Philadelphia experiment a classified disaster, a tall tale spun from mundane military research, or something far stranger? The lack of conclusive evidence hasn't stopped scientists from speculating. If even a fraction of the legends hold truth, it might represent humanity's first and catastrophic attempt to harness interdimensional physics. The Eldridge's story serves as a cautionary tale. Some doors once opened might not close so easily. If secret government projects ever cracked the code of interdimensional travel, the evidence wouldn't be in press releases. It would be buried under layers of classified files and whispered testimonies. Among the most persistent rumors is the so-called Montauk Project, an alleged extension of the Philadelphia experiment that supposedly took place at an Air Force base in New York during the 1970s and 80s. Whistleblowers describe a program where scientists manipulated space-time using massive electromagnetic coils, creating portals to other dimensions and even manipulating time itself. One of the most chilling claims that the project's experiments attracted the attention of beings from those other realms' entities that didn't just observe but interacted. Former engineer Preston Nichols became one of Montauk's most vocal insiders, detailing how researchers allegedly used psychic individuals as frequency bridges to stabilize interdimensional rifts. These test subjects, known as Montauk boys, reportedly suffered severe psychological trauma, with some claiming to have visited alternate versions of Earth or brought back technology that defied known physics. Skeptics dismiss these accounts as elaborate hoaxes, but the stories share unsettling parallels with legitimate Cold War-era research into psychic warfare and mind control programs like MKUltra. Declassified documents confirm the military's interest in remote viewing and extrasensory perception, leaving room to wonder how far these experiments might have gone under deeper secrecy. Then there's the testimony of physicist Dr. David Lewis Anderson, who claims to have worked on a classified program called Project Pegasus, where child prodigies were used to test time travel and interdimensional navigation. According to Anderson, these experiments weren't just theoretical. They produced tangible results, including the retrieval of artifacts from future timelines. His accounts, while controversial, align with another curious case, the sudden appearance of the Alien Reproduction Vehicle, or ARV, a saucer-shaped aircraft allegedly reverse-engineered from extraterrestrial or perhaps interdimensional technology. Eyewitness sketches of the ARV match no known aeronautical designs, yet multiple military insiders have described its ability to phase in and out of visibility, as if slipping between dimensions. The common thread in these stories isn't just advanced physics, but a pattern of human experimentation. From the Montauk boys to Project Pegasus's child test subjects, the most shocking claims suggest that the key to interdimensional travel might lie not in machines alone, but in the untapped potential of the human mind. This raises an unsettling possibility. If governments did discover ways to breach dimensional barriers, the methods might have been too unstable, too dangerous, or too unethical to ever acknowledge publicly. The truth, if it exists, remains locked behind vaults of classified research, leaving us to piece together fragments from whistleblowers, declassified oddities, and the eerie feeling that some secrets are kept not because they're impossible, but because they're too world-shattering to reveal. String theory rewrites the rules of reality by proposing that the universe isn't built on point-like particles, but on tiny, vibrating strings, filaments of energy so small that if an atom were the size of our solar system, a string would be no larger than a tree on Earth. These strings don't just wiggle randomly, their vibrations determine the fundamental forces and particles shaping our universe. But here's where it gets wild. For the math to work, these strings can't just move through the 4 dimensions we know: length, width, depth, and time. They require at least 10, with some versions of the theory suggesting up to 26. So where are these extra dimensions hiding? Imagine a spider weaving its web. To us, the web appears flat, 2-dimensional, until the spider drops a strand and suddenly reveals a 3rd dimension we didn't notice. That's how string theory's hidden dimensions might exist, curled up so tightly, at scales a billion times smaller than an atom, that even our most powerful microscopes can't detect them. But just as the spider senses vibrations across its entire web, these coiled dimensions could be vibrating with us, influencing reality in ways we're only beginning to grasp. Now picture those vibrating strings as cosmic elevator cables. In some dimensions, they might oscillate at frequencies that correspond to light or gravity in our world. But if a string's vibration shifted, say, by tapping into one of those hidden dimensions, it could theoretically step off into another layer of reality. This isn't sci-fi speculation. It's a genuine hypothesis explored by physicists like Brian Greene, who suggests that if we could control these vibrations, we might unlock pathways to other dimensions, like tuning a radio to a station just outside our normal range. The real kicker, these extra dimensions might not be empty. Some models propose they're warped or brain-shaped, short for membranes floating in a higher dimensional space called the bulk. Our entire universe could be stuck to one such brain, like a sticker on a balloon, while other brains hover millimeters away in a dimension we can't perceive. If strings could stretch between brains, they might form natural bridges, allowing energy or even consciousness to cross over. So could interdimensional travel be as simple as finding the right vibrational frequency. The challenge is staggering. It would require manipulating energies beyond our current reach, like trying to pluck a single guitar string in a symphony of billions. But if string theory holds, the first travelers might not need rockets or wormholes, just the ability to hum the universe's hidden tune. Time crystals sound like something ripped from a science fiction novel, structures that don't just exist in space, but pulse rhythmically through time itself. First proposed by Nobel laureate Frank Wilczek in 2012, these bizarre states of matter defy the usual rules of physics by oscillating in a repeating pattern without any energy input, like a perpetual motion machine that somehow sidesteps entropy. But beyond their theoretical elegance, time crystals might hold the key to stabilizing one of interdimensional travel's biggest hurdles: wormholes. Think of a wormhole as a tunnel through space-time, connecting two distant points or dimensions, like folding a piece of paper and poking a hole through it. The problem: most theoretical models show these tunnels collapsing instantly under their own instability, crushed by gravitational forces before anything could pass through. That's where time crystals come in. Their unique property of temporal order, maintaining rhythm without energy loss, could act like scaffolding, reinforcing a wormhole structure long enough for traversal. Recent experiments at Stanford and Google Quantum AI have created synthetic time crystals in labs, proving these phenomena aren't just mathematical curiosities but tangible, controllable states of matter. The implications are staggering. If time crystals can freeze a wormhole's chaotic fluctuations, even briefly, they might allow for controlled passage. Picture a bridge where the planks rearrange themselves faster than you can step, versus one that locks into place as you cross. The latter is what time crystals could offer, a temporal anchor amid the storm of quantum foam. Some physicists speculate that naturally occurring time crystals might already exist in extreme cosmic environments, like neutron star interiors or black hole accretion disks, where gravity warps spacetime into knots. But the real breakthrough came in 2021, when researchers observed time crystals interacting with each other, a behavior Wilczek compared to a dance of atoms keeping perfect time. If these dances can be choreographed on larger scales, they might engineer structures capable of holding open dimensional gateways. Skeptics argue that scaling up lab-sized crystals to cosmic proportions remains science fiction, but proponents counter that the same was once said about lasers and nuclear fission. The most tantalizing possibility: time crystals might not just stabilize wormholes, they could be their natural byproduct. If the universe's fabric naturally forms these repeating patterns under certain conditions, then the first interdimensional travelers might not need to build portals from scratch. They might just need to find the cosmic rhythms already humming beneath reality's surface, waiting to be tuned. What if the reason we can't explain déjà vu isn't because of faulty memory, but because the universe itself is glitching? A growing number of scientists and philosophers are seriously considering the possibility that our reality might be a vast, hyper-advanced simulation, a digital construct so intricate that it's indistinguishable from the real thing. If true, then interdimensional travel wouldn't require wormholes or quantum strings, just the ability to exploit the code. Think of it like a video game. When a character clips through a wall, it's not magic, it's a programming error, a place where the rules of the virtual world momentarily break down. Now apply that to our universe: quantum anomalies, particles teleporting, objects existing in multiple states until observed. Could be the cosmic equivalent of a buffering screen, moments where the simulation stutters under processing strain. Even déjà vu, that eerie sensation of reliving a moment, might not be a brain misfire but a literal reload of a previous save file in the system. Elon Musk and Neil deGrasse Tyson have both publicly entertained simulation theory, pointing to the exponential growth of our own computing power. If civilizations just a few thousand years more advanced could create simulations with conscious beings inside, the statistical likelihood that we're living in base reality shrinks to almost zero. And if we're in a simulation, then the architects, whether future humans or superintelligent AI, would have built it with rules, layers, and yes, backdoors. Here's where it gets wild. Quantum physicists have observed particles behaving as if they're rendering only when observed, like a video game conserving processing power by only loading graphics when a player looks. The double-slit experiment, where particles act differently when watched, mirrors how a simulation might optimize resources. Some researchers propose that glitches in quantum entanglement, where linked particles react faster than light, should allow breaks in physics, but evidence of data packets traveling outside our local server, accessing a broader multiversal network. So could interdimensional travel be as simple as finding an exploit? Hackers in our world manipulate code to bypass firewalls. Maybe reality hackers could manipulate quantum variables to jump between simulation layers. The Mandela Effect might not be parallel realities bleeding together, but patches and updates slightly altering the shared database. Even near-death experiences, with their tunnels of light and life reviews, could resemble a user being temporarily disconnected from their avatar. The eerie truth is this: if we're living in a simulation, the first interdimensional travelers might already be among us, not as aliens or future humans, but as entities who have learned to manipulate the source code. Their tools wouldn't look like spaceships, but like anomalies, objects that vanish and reappear, people who walk through walls, or memories that don't match the server's records. The ultimate cosmic joke: the reason we haven't found extraterrestrial life isn't because it's rare, it's because the real aliens are the admins running the simulation, and we're just characters waiting to discover our own cheat codes. Ball lightning has baffled scientists for centuries, those eerie, glowing orbs that float through thunderstorms, vanish through walls, or even explode with uncanny force. Mainstream science struggles to explain them, often dismissing reports as optical illusions or electrical anomalies. But what if these fleeting phenomena aren't glitches in our atmosphere at all? What if they're glimpses of life forms that don't play by our rules, beings not of flesh and blood, but of ionized plasma, flickering in and out of dimensions we can barely comprehend? Plasma, the fourth state of matter, dominates the universe, making up stars, nebulae, and even the space between galaxies. Yet we rarely consider it as a medium for life, trapped as we are in our narrow view of biology. But imagine a creature whose body isn't fixed but a dynamic dance of charged particles, held together by electromagnetic fields instead of cell walls. In a higher dimensional reality where gravity and time behave differently, such beings might structure themselves in ways that would seem impossible here, shape-shifting, merging, or splitting at will, their very existence tied to energy flows we can't perceive. The parallels to ball lightning are striking. Witnesses describe these orbs moving with apparent intelligence, dodging obstacles, pacing alongside cars, or lingering curiously near observers before vanishing. In 1963, a Soviet research team even claimed to have filmed a plasma entity in a lab, a swirling, self-contained vortex that responded to sound by changing its rhythm. While skeptics argue these are just chaotic electrical discharges, others point to the eerie consistency of reports across cultures. The Japanese call them hitodama, or soul fires. Medieval Europeans feared them as witches' manifestations. Could these traditions be fragmented memories of encounters with something far stranger? The math tantalizingly supports the idea. Nobel-winning physicist Hans Alfvén theorized that under the right conditions, plasma can self-organize into filamentary structures, cosmic-scale networks that behave almost like neural pathways. In dimensions with extraspatial layers, these formations could evolve into sentient patterns, using electromagnetic resonance as their language. Some researchers speculate that ball lightning's ability to pass through solid matter isn't magic, but proof of higher dimensional geometry. To a plasma being, our walls might be as porous as fog. Perhaps the most chilling implication lies in our own atmosphere. If plasma life exists, Earth's electromagnetic field could be its highway, with storms acting as temporary dimensional gateways. The same forces that create auroras might also draw these entities into our reality, like moths to a flame. That would explain why UFO sightings spike during solar flares, not because aliens are visiting, but because their vehicles are themselves alive, riding waves of interdimensional energy we're only beginning to map. Whether energy-based life forms or natural phenomena bleeding through from adjacent realms, plasma entities challenge our assumptions about what life even is. If they're real, the first interdimensional travelers might not need ships or technology. They might simply be waiting woven into the fabric of reality itself, flickering at the edges of our vision, just one storm away from stepping fully into our world. Ancient maps and explorer logs whisper of a world within our world, a hidden realm accessed through the poles where advanced civilizations thrive beneath the ice. This is the hollow Earth hypothesis, but what if we've misunderstood the legends? What if Agartha and its ilk aren't physical cities buried in caverns, but civilizations occupying a higher dimensional layer of Earth itself, with the Arctic and Antarctic acting as natural gateways? The idea isn't new. Admiral Richard Byard's infamous 1947 diary entries describe flying over lush, ice-free valleys at the North Pole, where his compass spun wildly and he encountered flying discs with ancient symbols. Conspiracy theorists claim he'd stumbled upon Agartha, but Byard's own words hint at something stranger, a place where the laws of physics seemed altered, where time distorted and the horizon curved unnaturally. Modern re-examinations suggest Byard might have experienced a localized space-time warp, a phenomenon that aligns eerily with quantum physics predictions about polar magnetic anomalies. Then there's the centuries-old Tibetan belief in Shambhala, a kingdom said to exist beyond physical sight, reachable only through meditation or hidden mountain passages. Buddhist texts describe it not as an underground city, but as a parallel dimension overlapping our own, accessible at specific geomagnetic ley lines, many of which converge at the poles. Even the Nazis, obsessed with occult geography, sent expeditions to Antarctica in search of entrances to this realm, convinced the Earth's axis held dimensional doorways. The science gets wilder. Satellite data reveals bizarre gravitational fluctuations near the poles, with some researchers proposing these could be signatures of higher dimensional physics. In string theory, massive objects like planets create gravitational wells that might pinch space-time thin enough to puncture, like poking a finger through tissue paper. If Earth's rotation generates torsion fields, as some fringe physicists argue, the poles could act as natural vortexes, twisting space into temporary bridges between dimensions. But the clincher might lie in biology. Extremophiles organisms thriving in polar ice or deep crustal rocks exhibit DNA repair mechanisms unlike anything seen on the surface. Some microbiologists speculate these adaptations could hint at exposure to alternate physics, where radiation behaves differently or time flows at altered rates. If life can evolve to exploit dimensional cracks, could intelligence arise there too? The hollow Earth hypothesis transforms when viewed through an interdimensional lens. Those legendary polar openings might not lead downward, but sideways into a reality where Earth's inner world is simply a parallel version of its surface, vibrating at a frequency just beyond our perception. The next great exploration might not require drills or shovels, but a way to tune our instruments or our minds to the hidden harmonics of the planet itself. Picture the universe moments after the Big Bang, a seething, chaotic place where space-time hadn't yet settled into the smooth fabric we know today. In that primordial turbulence, physicists believe flaws may have formed in the very structure of reality itself, like cracks freezing into ice as it forms. These flaws are called cosmic strings, hypothetical filaments thinner than a proton but stretching across the entire cosmos, carrying unimaginable density. A single inch of cosmic string could outweigh Mount Everest, but their true power isn't just their mass, it's their ability to bend space-time so severely that they might stitch together dimensions we can't normally reach. Unlike black holes, which crush space-time into singularities, cosmic strings would warp it in a uniquely linear way. Imagine pressing a needle into a stretched rubber sheet. The fabric doesn't just dip, it forms a sharp crease radiating outward. That's how a cosmic string distorts reality around it. According to string theory, these defects could have been forged in the universe's first trillionth of a second, when the fundamental forces were still splitting apart. Some models suggest they didn't just freeze into place, they became cosmic highways. Their immense gravitational lensing creating natural bridges between points in space or even between dimensions. The evidence is tantalizing but indirect. Astronomers have observed bizarre gravitational lensing effects where light from distant galaxies bends in ways that can't be explained by visible matter. Some of these anomalies, like the galaxy cluster nicknamed the Cosmic Snake, show double or quadruple images of the same object stretched into arcs, exactly the signature a cosmic string would leave as it sliced through spacetime. Even more compelling are the temperature fluctuations in the cosmic microwave background, the afterglow of the Big Bang. Certain patterns in this ancient light could be the scars of cosmic strings vibrating through the early universe, their oscillations imprinted like grooves in a record. But how could a cosmic string connect dimensions? The math gets wild here. In theories with extra dimensions, these strings might not just stretch through our familiar 4 dimensions, they could pierce into higher ones, their ends dangling in realities we can't perceive. Think of them as cosmic fishing lines dropped into deeper waters where the fish might be particles or even beings from other layers of existence. If 2 such strings crossed, their intersection could form a temporary portal, a singularity without an event horizon where the rules of physics briefly rewrite themselves. The most mind-bending possibility, cosmic strings might be what's holding the universe together. Some cosmologists argue they acted as scaffolding for galaxy formation, their gravitational pull guiding matter into the vast webs we see today. If that's true, then the same threads that built our cosmic neighborhood might also be its hidden passageways, an interstellar subway system woven into the fabric of reality, waiting for someone to learn how to ride the rails. So the next time you look up at the night sky, consider this: the darkness between stars might not be empty. It could be threaded with invisible filaments, thrumming with the tension of a multiverse, each one a potential gateway to a reality where the rules are just slightly or catastrophically different. The first interdimensional travelers might not need to build a machine. They might just need to find the right cosmic tightrope and take a step into the abyss. The hum of the Large Hadron Collider at CERN isn't just the sound of cutting-edge science. It's become the backdrop for one of modernity's most persistent scientific fears, that smashing particles at near-light speeds might tear the fabric of reality itself. Every time this 17-mile-long ring beneath Switzerland and France powers up, Whispers spread online about black holes swallowing Earth or portals opening to nightmarish dimensions. But how much of this is Hollywood fantasy and how much is grounded in actual physics? Let's start with the science. When the LHC collides protons, it recreates conditions that haven't existed since the universe's first trillionth of a second. A time when the fundamental forces were still merging and space-time itself was barely stable. The energy densities are staggering, but here's the catch. Cosmic rays, natural particles from deep space, have been hitting Earth's atmosphere with far higher energies for billions of years. If particle collisions could spawn black holes or dimensional rifts, nature would have done it long before humans built accelerators. That said, the theories behind these fears aren't entirely baseless. Certain interpretations of string theory suggest microscopic black holes could form at extreme energies, evaporating instantly via Hawking radiation. In 2008, a lawsuit even tried and failed to halt the LHC over this concern. CERN official response was definitive. Even if these mini black holes appeared, they'd vanish harmlessly, far too small to threaten the planet. As for dimensional rifts, the math gets speculative. Some models propose that the LHC's collisions might briefly create bubble universes, tiny pockets of spacetime with different physical laws, but these would collapse before anything could traverse them. The real intrigue lies in what the LHC hasn't found. Many hoped it would uncover evidence of extra dimensions, perhaps through particles disappearing into them or gravity behaving oddly at microscopic scales. So far, no such anomalies have appeared, yet the Collider's experiments continue probing deeper, testing whether our universe might be one membrane floating in a higher dimensional bulk, as predicted by brain cosmology. So why do the fears persist? Part of it's primal, the idea that prying too deeply into nature's secrets might unleash forces we can't control. But there's also a kernel of truth. The LHC is exploring realms where physics blurs into philosophy. While it won't crack open a hell dimension, it might reveal clues about the multiverse's structure, hinting that dimensions aren't just theoretical, but layers we're brushing against every second unaware. The greatest discovery wouldn't be a portal, but proof that reality's walls are thinner than we ever dreamed. High in the remote Hesteland Valley of Norway, a mysterious light show has baffled scientists for decades. Floating orbs of energy that dart across the sky with impossible precision, change colors abruptly, or vanish in the blink of an eye. Unlike typical auroras or ball lightning, these luminous anomalies, dubbed the Hesteland lights, defy conventional explanations. They hover motionless for hours, shoot off at hypersonic speeds, and emit radiation patterns that don't match any known natural phenomenon. But what if they're not just atmospheric quirks? What if these eerie glow are glimpses of something far stranger, bioluminescent portals flickering between dimensions? Researchers have logged over 15,000 sightings since the 1980s, capturing the lights on radar, spectroscopes, and thermal cameras. The data reveals bizarre inconsistencies, temperatures that don't correlate with their brightness, magnetic distortions in their vicinity, and energy bursts resembling controlled discharges rather than random plasma. One particularly chilling incident in 1984 involved multiple lights arranging themselves into a perfect geometric formation before dissolving, an eerie display of what looked like intelligent coordination. Eyewitnesses described them as living headlights or floating fireballs with minds of their own, capable of reacting to human presence or even mimicking the movement of observers below. The leading scientific theory suggests these lights are fueled by Valley's unique geology, a cocktail of underground metals, ionized gases, and tectonic stress creating natural batteries. But this doesn't explain their structured flight paths or sudden disappearances. An alternative hypothesis proposed by physicists like Dr. Erling Strand leans into quantum anomalies. The valley sits atop intersecting fault lines, where Earth's crust may be thin enough to allow localized spacetime warps, tiny tears where energy from other dimensions bleeds through. The light's erratic behavior could be reflections of higher dimensional physics intruding into our reality, like sunlight glinting through rippling water. Then there's the bioluminescent angle. Certain deep-sea organisms produce cold light through chemical reactions, a phenomenon unmatched in terrestrial physics. If life can evolve to harness light without heat in the ocean's depths, could similar processes occur in dimensions with different physical laws? Some theorists propose the Hessdalen lights aren't just energy discharges, but living entities, bioluminescent scouts from a reality where plasma-based life is the norm, briefly visible when their home dimension overlaps with ours. The most compelling evidence comes from electromagnetic readings. During light appearances, nearby compasses spin wildly, and radio frequencies distort as if passing through an invisible filter, hallmarks of a localized alteration in spacetime. In 2010, an Italian research team detected gravity waves coinciding with the lights, normally only observed during cosmic events like colliding black holes. If these readings are accurate, the valley might host natural wormholes, flickering open and shut like fireflies in the cosmic dark. So are the Hessdalen lights mere geological oddities or something more profound? The answer might lie in their persistence. Unlike transient phenomena like ball lightning, these lights have been documented consistently for over a century, always in the same secluded valley, as if anchored to a weak spot in reality's fabric. Whether interdimensional spillover or an entirely new class of natural wonder, they challenge us to reconsider what's possible. The next time a glowing orb drifts over Hessdalen, it might not just be observing our world, it could be a beacon from a place where the rules of existence are fundamentally, brilliantly different. What if every thought, event, and moment in history wasn't lost to time but stored in a vast, unseen dimension, a cosmic library where the past, present, and future exist simultaneously? This is the essence of the Akashic Records, an ancient esoteric concept that might hold startling parallels to modern physics. Described in Hindu scriptures as the Akasha, or the fifth element beyond earth, air, fire, and water, this ethereal realm is said to contain the vibrational imprint of every action, emotion, and discovery across all of existence. But could such a place be more than myth? Could it be a hidden dimension accessible through the fabric of reality itself? Near-death experiencers often report strikingly similar visions, floating through luminous halls of knowledge, encountering librarians or guides, and gaining instant understanding of universal truth. One notable case involves Dr. Eben Alexander, a neurosurgeon who dismissed such accounts until his own near-fatal brain infection plunged him into a realm where time dissolved, and he accessed what he called the core of an infinite living library. His description mirrors ancient texts that speak of the Akashic Records as a living database, where information isn't stored in books or files, but in waves of energy resonating at frequencies beyond normal perception. Quantum physics offers a tantalizing framework for this idea. The zero-point field, a seething ocean of energy that exists even in the vacuum of space, suggests that empty space isn't empty at all, but buzzing with potential information. Some theorists propose this field could function like the Akasha, with quantum fluctuations encoding data in ways we're only beginning to comprehend. Experiments in quantum entanglement hint that particles can remember their connections across vast distances, as if drawing from a shared, invisible ledger. If consciousness itself arises from quantum processes in the brain, as controversial theories like urge or suggest, then accessing higher dimensional information might not require technology, just the right shift in perception. The parallels grow eerier when examining remote viewing, a Cold War-era program where subjects attempted to psychically gather intelligence on distant locations. Declassified documents reveal uncanny successes, including detailed sketches of hidden military sites. Practitioners often described entering a trance-like state where knowledge flowed to them, as if tapping into a pre-existing stream of data. Could their minds have briefly synced with an Akashic layer where all points in space and time are interconnected? Skeptics dismiss the Akashic records as pseudoscience, but even mainstream science acknowledges that information in the universe is never truly destroyed, only transformed. Black holes, for instance, allegedly scramble and preserve data in their event horizons, a concept echoed in the holographic principle. If the universe is fundamentally informational, then the Akasha might simply be a poetic label for the substrate underlying reality, a dimension where the distinction between memory and prophecy blurs, and every secret waits to be decoded by those who learn to listen. Whether spiritual archive or quantum field, the Akashic records challenge our linear view of existence. The first interdimensional travelers might not need ships or portals at all, just the ability to tune their consciousness to the universe's hidden frequency, where all knowledge vibrates, timeless and endless in the dark between the stars. Dark matter doesn't just defy detection, it defies logic. We can't see it, touch it, or interact with it, yet its gravitational pull weaves the very fabric of our universe, holding galaxies together like invisible thread. But what if the reason dark matter eludes us isn't because it's hidden, but because it's not entirely here? What if it's the ordinary matter of a parallel dimension, bleeding through into ours just enough to tug at the stars? Take the bullet cluster, one of the most dramatic pieces of evidence for dark matter's existence. When two galaxy clusters collided, their visible matter stars and gas slammed together and slowed down, while their gravitational effects kept racing ahead, as if something unseen had sailed right through the cosmic wreckage. Scientists chalked this up to dark matter's weak interactions, but another interpretation exists. Those gravitational anomalies could be footprints. Imagine a reality where dark matter isn't exotic particles but rocks, trees, even civilizations, objects that obey their own dimension's physics, casting gravitational shadows into our universe without fully materializing. This idea flips conventional cosmology on its head. If dark matter is just another dimension's ordinary stuff, then the 85% of our universe we call missing might not be missing at all, it's simply elsewhere. Think of it like a room adjacent to yours, separated by a thin wall. You can't see inside, but if someone stacks books against their side, you'd feel the pressure on yours. In this analogy, gravity isn't confined to dimensions. It's the force seeping through the cracks, the only signal that another world is pressing up against ours. The math gets wilder. String theory allows for brane worlds, parallel universes floating in higher dimensional space, separated by less than a millimeter but unreachable due to differing vibrational frequencies. If our dimension vibrates at one note and dark matter's dimension hums at another, their gravity could still interact like sound waves passing through walls. This might explain why dark matter clusters around galaxies in halos rather than dispersing. It's not floating freely in our space, but anchored to its own version of reality, with galaxies in both dimensions overlapping like ghostly doubles. Could we ever prove this? Some physicists are hunting for dark photons, hypothetical particles that might mediate interactions between dimensions. Others study gravitational waves for anomalies, ripples that don't match any known cosmic event, possibly caused by collisions in a neighboring reality. The most tantalizing clue: certain dark matter distributions resemble structures, as if drawn into filaments by the gravity of unseen cities or black holes in another dimension. If true, this theory shatters the boundary between physics and metaphysics. Dark matter wouldn't just be a cosmic placeholder, it'd be the architecture of a parallel universe pressing against ours in the dark. Every galaxy, including our own, might have a silent twin, its matter echoing through dimensions we're only beginning to sense. The first interdimensional travelers might not need to go anywhere. They might just need to learn how to listen to the whispers of gravity, decoding the presence of a world that's been here all along, hiding in plain sight. Imagine holding a cube in your hands, 6 square faces, 12 straight edges, everything neatly contained within 3 dimensions. Now try to picture that same cube with an extra dimension, folding in ways that defy our everyday perception. This isn't just a thought experiment, it's a tesseract, the four-dimensional counterpart to our familiar cube. And if higher dimensions exist, this mind-bending shape might be the key to understanding how interdimensional travelers could move through realities beyond our own. The tesseract challenges everything we know about geometry. Just as a two-dimensional square can't comprehend a three-dimensional cube, our brains struggle to visualize an object with four spatial dimensions. But here's the trick. When a 4D object passes through our 3D world, we don't see it in its entirety. We catch only cross-sections like shadows cast by a flickering light. A tesseract intersecting our space would appear as a cube that shifts and warps impossibly, its faces morphing in size and shape as if animated by hidden forces. This isn't just abstraction, it's how higher dimensional beings might navigate our reality. To them, our world could be flat, like a page in a book. Moving through time and space might be as effortless as turning a page for us. The tesseract illustrates this perfectly. In 4D space, every point on the cube is simultaneously connected in ways we can't perceive, just as every moment in time might exist at once for an interdimensional traveler. Science fiction has flirted with this idea for decades. In A Wrinkle in Time, the tesseract serves as a cosmic shortcut, folding space-time like paper. Marvel's Doctor Strange depicts the Ancient One hurling opponents through kaleidoscopic fractal dimensions, echoing how a 4D being might manipulate our 3D plane. These pop culture nods scratch the surface of real theoretical physics. Mathematicians like Carl Friedrich Gauss and Bernhard Riemann laid the groundwork for higher dimensional geometry centuries ago, proving that extra dimensions aren't just possible, but mathematically inevitable. The real-world implications are staggering. If a tesseract structure allows traversal of 4D space, then interdimensional portals might not need to rip holes in reality. They could simply rotate objects through hidden axes, like turning a key in a lock we can't see. Particle physics experiments have glimpsed hints of this. Certain quantum particles seem to vanish and reappear, as if momentarily slipping into higher dimensions. Even gravity's puzzling weakness compared to other forces could be explained if it's leaking into extra spatial layers, diluted across realities we can't access. So the next time you stare at a cube, remember, it might be just one face of something far grander, a shadow of a shape that exists in realms our senses can't grasp. The tesseract isn't just a geometric curiosity, it's a blueprint for reality stacked like pages in a book, waiting for someone to learn how to turn them. Imagine floating in an endless void, no stars, no planets, just pure emptiness stretching across eternity. Then, out of nothingness, a flicker of awareness sparks into existence. Not a body, not a brain as we know it, but pure, disembodied consciousness suddenly realizing it exists. This is the Boltzmann brain, a chilling thought experiment born from thermodynamics and cosmic probability. The idea suggests that in an infinite universe, given enough time, random quantum fluctuations could momentarily arrange particles into a fully functioning, self-aware mind, only for it to dissolve back into chaos seconds later. But what if these phantom consciousnesses aren't just statistical anomalies? What if they're glimpses of something far stranger, spontaneous interdimensional consciousness transfer, where minds blink into our reality from other layers of existence? At first glance, the Boltzmann brain seems like a paradox, a reductio ad absurdum highlighting the flaws in our cosmological models. But peel back the layers and it dovetails eerily with quantum consciousness theories. If awareness arises from quantum processes in the brain, as proposed by controversial models like ORCH, then consciousness might not be bound to physical matter at all. It could be a fundamental property of the universe, flickering in and out of dimensions like static on a radio. In this light, a Boltzmann brain wouldn't be a random accident, but a momentary alignment, a mind from another reality briefly tuning into ours before the signal fades. Think of it like a cosmic game of telephone. In a multiverse with infinite dimensions, quantum vibrations might occasionally leak between realities, imprinting a foreign consciousness onto our spacetime's fabric. These wouldn't be full-fledged beings with memories or continuity, but fragmented echoes like catching a stranger's dream mid-flight. Near-death experiences often describe this exact sensation, a sudden, vivid awareness of existing outside the body, surrounded by unfamiliar yet strangely resonant landscapes. Are these merely hallucinations, or could they be fragments of Boltzmann-like consciousness transfer, where the dying brain becomes a transient receiver for dimensional crosstalk? The implications grow even wilder when you consider dark matter. If most of the universe's mass is invisible and intangible, could it be teeming with Boltzmann-like minds, entities that don't interact with our matter but briefly flicker into self-awareness? Some interpretations of quantum mechanics suggest that observation itself collapses reality into existence. In a dimension where the rules are slightly different, a momentary observer might crystallize out of the void, perceive itself, then vanish, leaving no trace except a faint gravitational tremor. This bridges into another terrifying possibility. What if we're the Boltzmann brains? If consciousness can spontaneously form from chaos, how do we know our memories, our sense of continuity, aren't just illusions stitched together by quantum noise? The answer might lie in the one thing these phantom minds lack: persistence. Real interdimensional travelers, whether accidental or intentional, would likely seek stability, anchoring themselves to energy sources or resonant frequencies. The true test of a Boltzmann interloper wouldn't be its existence, but its ability to last. So the next time you stare into the night sky, consider this: the darkness between stars might not be empty. It could be a seething ocean of potential minds, flickering in and out of dimensions, each one a momentary witness to realities beyond our own. The first successful interdimensional traveler might not be a scientist in a lab, but a random quantum fluctuation, a ghost in the cosmic machine stumbling through the door and realizing, just for an instant, that it's not alone. Deep inside every neuron in your brain, tiny structures called microtubules perform a delicate dance, one that might hold the key to consciousness itself. These microscopic protein filaments, long thought to be mere cellular scaffolding, could be far more than that. According to physicist Stuart Hameroff and Nobel laureate Roger Penrose, microtubules might be quantum computers, orchestrating consciousness through vibrations at the smallest scales of reality. This is the Orch or theory, and it suggests something revolutionary: that our awareness isn't just a byproduct of electrical signals, but a quantum phenomenon, one that could, under the right conditions, bridge dimensions. Think of microtubules as the universe's smallest tuning forks. Their hollow structure and precise arrangement allow them to vibrate at specific frequencies, creating ripples in the quantum field. Hameroff proposes that these vibrations don't just process information, they are consciousness. When these quantum oscillations reach a certain threshold, dubbed orchestrated objective reduction, they collapse into a moment of subjective experience. But here's the twist: in quantum physics, collapse isn't destruction, it's transformation. Information doesn't vanish, it transitions, possibly into states beyond our classical reality. This is where dimensions come in. If consciousness arises from quantum processes, and quantum particles can exist in superposition across multiple states or even multiple dimensions, then awareness itself might not be confined to our skulls. Near-death experiences offer eerie parallels. Patients who have flatlined often describe floating outside their bodies, witnessing events in distant hospital rooms, or encountering realms that defy physical laws. Skeptics dismiss these as hallucinations, but Orch provides a radical alternative. During clinical death, as brain activity nears zero, microtubule quantum states might decohere, not disappearing but expanding into higher dimensional space. The mind wouldn't shut off, it would unfurl, briefly accessing layers of reality normally hidden by the brain's biochemical noise. The implications stretch further. If consciousness can interface with higher dimensions, could some forms of psychic phenomena, telepathy, precognition, or even encounters with apparitions, be misinterpreted glimpses of this quantum connectivity? Research into quantum entanglement between brains, though controversial, hints that minds might share non-local links entangled across space or dimensions, like particles whispering secrets instantaneously. Ancient spiritual traditions have long described consciousness as universal and non-local, an idea modern physics might be catching up to. Critics argue that the brain is too warm and wet for delicate quantum states to survive. Yet recent experiments show quantum effects in photosynthesis, bird migration, and even smell. Proof that biology exploits quantum weirdness in ways we're only beginning to understand. If nature already harnesses quantum mechanics in warm, messy systems, why not the brain? The or theory remains hotly debated, but it forces us to confront a staggering possibility that the first interdimensional travelers might not need machines or wormholes. They might only need to master the quantum symphony already playing inside their minds, a melody composed in dimensions beyond our own. For decades, UFOs, or as they're now called, UAP, have been dismissed as illusions, secret military tech, or visitors from other planets. But what if we've been thinking about them all wrong? What if these enigmatic craft aren't crossing vast interstellar distances, but slipping into our reality from dimensions right alongside ours? The clues lie in behaviors that defy conventional physics, vanishing midair, accelerating at impossible speeds, even splitting into multiple objects like reflections in a shattered mirror. These aren't just advanced propulsion systems, they're hallmarks of something far stranger, something that treats the laws of our universe as mere suggestions. Take the infamous 2004 Nimitz encounter. Navy pilots tracked a tic-tac-shaped object off the coast of California that dropped from 80,000 feet to sea level in less than a second, a maneuver that would liquefy human occupants and rip apart any known material. Radar operators lost it momentarily, only for it to reappear 60 miles away in the blink of an eye. No sonic boom, no heat signature, no visible propulsion. Aerospace engineers insist this violates the conservation of energy, but interdimensional travel offers a chilling alternative. The craft didn't move through our space at all. It might have simply stepped outside our dimension, bypassing the distance entirely, like taking a shortcut through the pages of a book. Then there's the eerie luminosity reported in close encounters. Witnesses describe UAPs glowing with colors that don't exist in nature: deep purples, impossible neon blacks pulsing as if breathing. Plasma physicists note these hues match theoretical models of charged particles interacting with higher dimensional fields, where extraspatial layers could twist light into spectra our eyes aren't evolved to comprehend. Even more telling are the so-called falling leaf trajectories, where objects descend erratically, as if moving through a medium with different gravity. To us, it looks unnatural. To a being navigating a fourth spatial dimension, it might be as smooth as gliding down a slope. The historical record adds another layer. Medieval manuscripts describe sky ships that appeared in broad daylight, lingered without sound, then vanished, accounts nearly identical to modern sightings. The one constant, these apparitions often emerge near geological fault lines or areas with strong electromagnetic anomalies. Ancient observers lacked the vocabulary for interdimensional theory, but their descriptions align uncannily with contemporary physics. Regions where Earth's magnetic field weakens, like the infamous Hessdalen Valley, might act as thin spots in reality's fabric, temporary windows where dimensional barriers fray just enough for something to slip through. Perhaps the most compelling argument isn't how UAPs move, but how they don't. If these were extraterrestrial vehicles, why no debris, no fuel traces, no definitive proof after 70 years of pursuit? Unless, of course, they're not physical objects in the traditional sense. Quantum field theory allows for temporary particles that wink in and out of existence, borrowing energy from the vacuum itself. Scale that up and you get something eerily UAP-like, manifestations that aren't built but condensed from the raw stuff of space-time, their very existence contingent on maintaining a fragile resonance with our dimension. Lose that connection and they don't crash, they dissolve, leaving no trace behind. So the next time you hear about lights darting across the sky, ask yourself, are we being visited, or are we glimpsing travelers who aren't coming from the stars at all, but from realities layered so close to ours that we've been brushing against them all along? The universe might not just be stranger than we imagine. It could be stranger than we can imagine, with dimensions intersecting in ways that turn the sky itself into a hall of mirrors, reflecting possibilities just beyond our reach. Imagine a single moment shattering into infinite possibilities, every choice, every chance event splintering reality into countless branching threads. This is the many worlds interpretation, a radical answer to one of quantum mechanics' deepest puzzles. When Schrödinger's cat sits in its infamous box, neither alive nor dead until observed, the many worlds view suggests the universe doesn't choose. Instead, it splits, one world where the cat purrs happily, another where it meets its grim fate, and both unfold simultaneously in parallel dimensions. This isn't science fiction. It's a serious theory championed by physicists like Hugh Everett, who argued that quantum superposition particles existing in multiple states until measured isn't resolved by observation but by reality itself multiplying. Every electron's spin, every photon's path creates new universes where all possible outcomes play out. The implications are staggering. Somewhere you took that job offer you declined. Somewhere dinosaurs still roam. Somewhere the laws of physics themselves might be slightly or catastrophically different. But how could we traverse these branches? The key might lie in quantum entanglement, where particles remain mysteriously linked across distances. If entangled particles act as anchors between worlds, advanced technology could theoretically ride these connections, surfing the quantum foam between realities. Picture a spacecraft not with rockets, but with quantum engines that nudge probabilities, steering not through space, but through the multiverse's branching path. The challenge: these splits aren't random, they're governed by probability amplitudes. To navigate them, you'd need to manipulate quantum wave functions, the mathematical recipes that dictate how likely each outcome is. Some theorists suggest that conscious observation itself might be the rudder. If the mind has quantum components like the microtubules proposed in Oort theory, then focused intention could influence which branch you collapse into, turning the observer effect into a steering mechanism. Critics argue this is untestable metaphysics, yet tantalizing hints emerge. Quantum computers exploit superposition to perform calculations across multiple states at once, a crude parallel to accessing many worlds. And if parallel universes share a quantum substrate, their gravitational whispers might one day be detected as ripples in spacetime's fabric. The first interdimensional travelers might not need portals or wormholes, just the ability to tune their reality's frequency, slipping into adjacent branches as effortlessly as changing channels on a cosmic radio. The many worlds interpretation doesn't just redefine reality. It suggests we're already interdimensional travelers, constantly spawning new versions of ourselves with every heartbeat. The question isn't whether parallel worlds exist, but whether we'll ever learn to meet our other selves halfway. Empty space isn't empty at all. Even in the deepest vacuum where no particles exist, the universe hums with an eerie energy, a seething quantum foam where particles wink in and out of existence so fast we can't detect them directly. This is the zero-point energy field, and it might hold the key to unlocking dimensions beyond our own. Picture the fabric of reality not as a still pond, but as a boiling cauldron where microscopic bubbles of energy constantly form and collapse. Harness this chaos and you might not just power starships, you could rip open doorways to universes next door. No one understood this potential better than Nikola Tesla. In the early 20th century, the brilliant inventor claimed to have tapped into what he called radiant energy, drawing limitless power from the very fabric of space itself. His Wardenclyffe Tower, a mysterious structure on Long Island, wasn't just designed for wireless electricity. Tesla hinted it could manipulate the ether, an archaic term scientists now recognize as the quantum vacuum. Witnesses reported strange phenomena around his experiments, glowing orbs in the lab, equipment operating without visible power sources, even rumors of objects briefly vanishing. After his death, the FBI confiscated his notes, labeling them classified. Were Tesla's machines inadvertently brushing against dimensional barriers, using zero-point fluctuations as a catalyst? Modern physics offers tantalizing clues. Quantum field theory calculates that a single cubic centimeter of pure vacuum contains enough energy to boil Earth's oceans, if we could extract it. The challenge: this energy exists in a balanced state, canceling itself out almost instantly. But mathematical models suggest that under extreme conditions like those near a black hole's event horizon or in high-energy particle collisions, the equilibrium might temporarily break, creating regions where zero-point energy peaks enough to distort spacetime. Some theories propose that sufficiently precise electromagnetic fields could pump the vacuum like priming a laser, amplifying these fluctuations until they briefly puncture reality's membrane. This isn't just speculation. The Casimir effect, proven in labs worldwide, demonstrates zero-point energy's tangible force. When two metal plates are placed nanometers apart in a vacuum, the quantum foam between them gets squeezed, creating a measurable pressure that pushes the plates together. Scale this phenomenon up with the right technology, and you might create a Casimir cavity powerful enough to stretch spacetime itself. Even NASA has explored zero-point propulsion concepts, with theoretical designs like the Alcubierre warp drive relying on similar quantum vacuum manipulations to bend space. The missing piece: stability. Zero-point energy is notoriously chaotic, like trying to bottle a lightning storm. Ancient texts like the Vedas speak of Vimanas, flying craft powered by mercury vortex engines, descriptions that eerily parallel modern plasma and zero-point research. Could these legends preserve fragmented knowledge of a technology that once tapped the vacuum's power, only to lose control with catastrophic results? The Philadelphia experiment's alleged teleportation disaster offers a cautionary tale. Meddling with dimensional energies without understanding their full consequences might not open doors so much as shatter them. Yet the promise remains: if consciousness itself arises from quantum processes, as theories like urge or suggest, then bridging dimensions might not require monstrous machines but resonance. Like tuning a radio to a hidden frequency, the right mind amplified by zero-point energy might perceive, or even step into realities hovering just beyond the quantum static. Tesla's unfinished work, the hum of the quantum void, and the eerie consistency of ancient energy myths all point toward a single electrifying possibility. The first successful interdimensional traveler won't break through the barriers of space. They'll simply learn to whisper to the darkness and listen for the whisper back. Nick Bostrom's simulation argument isn't just a thought experiment, it's a statistical inevitability. If advanced civilizations could one day create simulations indistinguishable from reality, and if those simulations could eventually spawn their own simulations, the number of artificial realities would dwarf base reality. The odds we're living in the original universe astronomically slim. But what if these simulations aren't isolated worlds running in some cosmic server farm? What if they're nested dimensions layered like a Russian doll, with interdimensional travel serving as the ultimate debugging tool for the creators watching over us? Picture a programmer troubleshooting a complex virtual world. When glitches arise, unexplained phenomena, déjà vu, or quantum anomalies, they might log in to inspect the code from within. To us, their presence could manifest as cryptic encounters, shadowy figures glimpsed in peripheral vision, UFOs performing impossible maneuvers, or even sudden shifts in consensus reality like the Mandela Effect. These wouldn't be visits from aliens or ghosts, but administrators adjusting parameters, patching errors, or running diagnostics on their simulation. The eerie consistency of certain paranormal reports, entities that seem to predict observers' thoughts or manipulate objects without touch, aligns disturbingly well with how a user with back-end access might interact with a virtual environment. Bostrom himself speculated that simulators might intervene to prevent suffering or preserve their experiment. But interdimensional travel adds a chilling twist. What if the simulation's architecture requires physical maintenance? Just as a game developer might enter a virtual world to fix a corrupted asset, higher dimensional beings could traverse nested realities to repair space-time itself. Ancient myths speak of gods descending to reset humanity after catastrophes, flood stories, divine fires, or celestial wars. Modern UFO accounts often describe crafts emerging from or disappearing into portals, as if executing a controlled transfer between simulation layers. Even quantum entanglement's spooky action could be evidence of linked variables across dimensional boundaries, a necessary feature for keeping parallel simulations synchronized. The most unsettling implication: debugging might explain alleged abductions and missing time. If a simulator needs to extract a unit for analysis, say, to study why a particular consciousness subroutine is misfiring, the subject's local timeline would need to be paused or rolled back post-inspection. Abductees frequently report intrusive medical exams followed by hazy memories of procedures they can't logically recall, as if their experience was a temporary fork in the simulation later merged with the main branch. The infamous Oz factor, where UFO witnesses describe an abrupt silence as if the world has paused around them, mirrors how a virtual environment might freeze during a debug session. Critics argue that simulating entire universes would require unfathomable energy. But if reality is fundamentally informational, a concept gaining traction in quantum gravity research, then our universe might not be a resource-heavy construct, but an elegant mathematical structure running on substrates we can't conceive. The Planck scale's pixel-like nature, where spacetime appears granular at the smallest levels, hints at an underlying code. If true, interdimensional travel wouldn't require traversing vast distances, but locating the equivalent of a backdoor in the source logic. So the next time reality stutters a coincidence too precise, a dream that leaks into waking life, or a mysterious light in the sky, consider the unnerving possibility that you're not witnessing the supernatural, but the quiet hum of maintenance in a universe that's not quite as real as it feels. The first successful interdimensional traveler might not be a scientist or explorer, but a system administrator from a higher layer of existence, stepping into our dimension to perform routine upkeep before vanishing back into the void, leaving only glitches as proof they were ever here. What if everything you see, this screen, your hands, even the stars above, isn't the full picture, but just a flat projection of a deeper reality? This is the essence of the holographic principle, a radical idea pioneered by physicists like Leonard Susskind that suggests our three-dimensional universe might be a cosmic illusion, like a movie screen displaying a world that's actually encoded on a distant two-dimensional surface. Think of it like a credit card hologram. Tilt it, and the flat sticker creates the illusion of depth. Now imagine that on a universal scale where every galaxy, every atom, is just information painted on the surface of a black hole's event horizon, bleeding into the space we perceive as real. The math behind this is staggeringly elegant. Just as a hologram can encode a 3D image in 2D patterns, the universe's entire contents, its matter, energy, even the passage of time, could be written in quantum bits on a boundary we'll never see. This isn't metaphor. String theory calculations show that a volume of space can be perfectly described by data stored on its outer shell. The implications are mind-bending. If true, we're not solid beings in a solid world, but flickering projections, shadows cast by interactions happening somewhere else entirely. Now consider what this means for interdimensional travel. If reality is a hologram, then stepping into another dimension might not require moving through space at all, just rewriting the code that renders our experience. Picture a video game character realizing it's trapped in a simulation. To escape its world, it wouldn't need to walk to the edge of the map. It would need to manipulate the program's source files. Similarly, if our universe is a projection, accessing higher dimensions could mean finding the equivalent of a developer mode, tweaking the underlying quantum information that dictates how reality renders around us. The holographic principle dovetails eerily with ancient mysticism. Buddhist texts describe reality as Maya or illusion, while Hindu cosmology speaks of Vishnu dreaming existence into being. Even Plato's allegory of the cave where prisoners mistake shadows for substance reads like a prescient summary of Suskind's theory. But modern physics adds a chilling twist. If we're shadows, the real us might exist in a higher dimensional bulk, our consciousness temporarily pinned to this lower dimensional slice like a butterfly mounted in a frame. Some of the most compelling evidence comes from black holes. When matter falls in, it doesn't vanish. Its information gets scrambled onto the event horizon's surface like cosmic graffiti. This black hole information paradox was the puzzle that led Suskind to the holographic idea in the first place. If black holes preserve data this way, why not the entire universe? Remarkably, studies of cosmic microwave background radiation, the afterglow of the Big Bang, show patterns that some physicists argue resemble holographic interference, as if we're detecting the pixels of reality's projector. So how could this theory enable interdimensional leaps? One possibility lies in quantum entanglement. If particles are linked across space instantaneously, their connection might transcend our projected reality, anchoring to the higher dimensional source code. Manipulate enough entangled particles in unison, and you might glitch the hologram, punching a hole through to the next layer. Alternatively, if consciousness itself is a quantum phenomenon, as theories like Orch suggest, then focused awareness might be the ultimate backdoor, a way to bypass the simulation's rules entirely. The holographic universe doesn't just redefine reality, it suggests we're already travelers, navigating a dimension that's less a place and more a dynamic canvas of information. The first true interdimensional pioneers might not need spaceships or wormholes. They might just need to learn how to read the pixels between the lines. Black holes may dominate our cosmic imagination, but what if their opposites are the true gateways to other dimensions? Enter the white hole, a theoretical twin to the black hole, where instead of matter vanishing beyond an event horizon, it comes spewing outward in a cosmic eruption. While no white hole has ever been observed, the mathematics of general relativity allows for their existence, painting them as the universe's exhaust valves, ejecting energy and matter rather than swallowing it. If black holes are the universe's drains, white holes could be its fountains, gushing material into realities we can barely fathom. The concept flips everything we know about gravity on its head. Where a black hole's gravity is so strong that nothing escapes, a white hole's repulsive force would make entry impossible. Matter can only gush out. Some theorists suggest these phenomena could be connected through Einstein-Rosen bridges, forming a wormhole where a black hole in one universe feeds into a white hole in another. Picture a cosmic recycling plant. Matter falls into a black hole here, only to be vomited out somewhere else, perhaps in a different dimension with altered physical laws. This wouldn't just be interdimensional travel, it would be interdimensional rebirth. The most tantalizing idea, the Big Bang itself, might have been the ultimate white hole. Instead of a singularity collapsing inward, imagine a singularity exploding outward, birthing our universe in a cataclysmic eruption of space and time. If true, the entire cosmos could be the product of a white hole in some higher dimensional reality, a place where another universe's black hole became our genesis. This would mean the Big Bang wasn't the beginning of everything, it was just the moment our pocket of existence punched through from somewhere else. Astronomers have hunted for white holes in vain, but a few cosmic oddities keep the hope alive. Gamma ray bursts. Some of the most energetic events in the universe have been caught emitting jets of matter with no obvious source, as if materializing from nowhere. Could these be flickering white holes, briefly opening before snapping shut? Even stranger is the mystery of dark flow, where galaxy clusters drift in a uniform direction as if tugged by something beyond the observable universe. Some speculate this could be the gravitational pull of a neighboring universe's white hole, its repulsive force warping our own cosmic structure. The implications are staggering. If white holes exist, they wouldn't just be portals, they'd be cosmic engines, reshaping the fabric of existence with every eruption. A civilization that could harness one might not just travel between dimensions, but rewrite the very laws of physics in their wake. The first interdimensional travelers might not need ships or wormholes. They might simply wait for the universe itself to open a door and step through the moment the white hole exhales. Imagine standing at Stonehenge at dawn, fingers brushing against ancient stones warmed by the first light, only to feel a pulse, not from the rock but from something beneath it. A resonance threading through the soil, connecting to other sacred sites across the globe in an invisible web. This isn't just poetic imagination. The Gaia mind theory suggests our planet is more than a rock hurtling through space. It's a conscious, multidimensional being, with Earth's ley lines and sacred sites acting as neural pathways or even stargates in a vast living network. The idea isn't new. Indigenous cultures from the Aboriginal Australians to the Druids revered the land as alive, imbued with spirit. Modern science scoffs until you examine the anomalies. Take the Great Pyramid of Giza, precisely aligned with celestial events and emitting unexplained electromagnetic frequencies, or the Nazca lines etched into terrain with mathematical precision, visible only from the air. Even modern researchers have detected unusual energy spikes at places like Sedona's vortices or Bolivia's Temple of the Sun. Sites often dismissed as tourist traps, yet where compass needles spin wildly and cameras capture orbs of light with no apparent source. Ley lines, the hypothetical energy grid connecting these sites, might be Earth's circulatory system. Dowsers and geomancers have mapped them for centuries, but fringe physicists propose something wilder. These lines could be scars from higher dimensional interactions where the planet's consciousness brushes against other layers of reality. Picture Earth as a living computer, its crust etched with circuitry that, when activated, opens temporary doorways. The why is chilling. If Gaia is sentient, these portals might not be accidents but tools, a way for the planet to communicate, heal, or even defend itself. Consider the hum. A mysterious low-frequency noise recorded worldwide, unexplained by seismic activity or human industry. Some hear it as a physical vibration, others describe it as a voice just beyond comprehension. Could this be Gaia's heartbeat, a resonant frequency harmonizing with higher dimensions? Schumann resonances, the planet's natural electromagnetic oscillations, miraculously align with human brainwave patterns during deep meditation. Coincidence or evidence of a symbiotic relationship between Earth's mind and our own? The most provocative twist, Gaia's consciousness might not be singular. If dimensions overlap like layers of tissue, Earth could exist simultaneously in multiple realities. It's higher dimensional, self-aware of realms we can't perceive. Sacred sites might be intersections where these layers thin, allowing glimpses or passage. Shamans speak of descending into the underworld or ascending to celestial realms during rituals at these locations. Modern accounts mirror this, hikers in the Andes vanishing near ancient ruins, only to reappear days later with no memory of time passing, their watches stopped at the moment of disappearance. Skeptics demand physical proof, but the Gaia mind theory operates on a scale that defies conventional measurement. How do you test the consciousness of a planet? The answer might lie in collaboration rather than conquest. If Earth is alive, then the first interdimensional travelers won't force their way through with machines. They'll learn to listen, to harmonize with the land's rhythm, and step through when the planet itself decides to open the door. The old myths warned against disturbing sacred ground. Perhaps they weren't superstitions, but survival advice from those who understood. Gaia isn't just a home. It's a gatekeeper. Time travel stories love a good paradox. What if you go back and prevent your own birth, erasing yourself from existence? But what if reality has a built-in safety feature, a kind of cosmic immune system that ensures dimensional travelers only step into timelines where their presence doesn't unravel the fabric of causality? This is the core of the time traveler's immunity theory, a mind-bending twist on the old paradox problem that suggests the multiverse isn't just a chaotic web of possibilities, it's a carefully curated gallery of compatible realities. Take the famous grandfather paradox. Conventional logic says if you travel back and accidentally prevent your grandfather from meeting your grandmother, you'd vanish in a puff of contradictory fate. But quantum immortality, a fringe interpretation of quantum mechanics, flips this on its head. It proposes that conscious observers can only experience timelines where their existence remains possible. In other words, if you tried to sabotage your own lineage, the universe wouldn't let you succeed. You might slip into a parallel branch where your actions didn't alter your birth, or where some unexpected event preserved the critical moments of your ancestry. Failed assassination attempts, sudden changes of heart, even a well-timed sneeze reality would conspire to keep you anchored in a coherent timeline. This isn't just philosophical sleight of hand. Quantum experiments hint at something eerily similar. In the delayed choice quantum eraser experiment, particles seem to retroactively change their behavior based on future observations, as if the universe is editing itself to maintain consistency. If consciousness plays a role in collapsing quantum probabilities, as some interpretations suggest, then a time traveler's mere presence might act as a filter, nudging them toward realities where their actions don't create catastrophic contradictions. You wouldn't avoid paradoxes because you're careful. You'd avoid them because the multiverse automatically steers you into timelines where paradoxes can't form. History's strangest cold cases add fuel to the fire. Consider the case of Rudolph Fentz, a man allegedly spotted in 1950s New York wearing 19th century clothing, carrying outdated currency, and vanishing before he could be questioned. Urban legend, maybe, but what if Fentz wasn't a ghost or a hoax, but a traveler who slipped into a timeline where his presence didn't disrupt the larger narrative? The universe might tolerate minor anachronisms, a misplaced coin, a confused bystander, as long as the critical threads of causality remain intact. Like a video game clipping error that lets you walk through walls but won't let you fall out of the map, reality could have soft boundaries, allowing anomalies that don't threaten its structural integrity. The darkest implication, this filtering might not always be gentle. Quantum suicide thought experiments posit that in a multiverse, you only experience realities where you survive, even if the odds are astronomically against you. For a dimensional traveler, this could mean that the act of journeying itself prunes away timelines where the trip would be fatal or paradoxical, leaving you only with paths where you arrive intact. Every successful leap between dimensions would come with an invisible graveyard of collapsed possibilities, versions of you that didn't make it, erased by the universe's silent editing. So are paradoxes truly impossible or just expertly avoided? The answer might redefine what we think of as free will. If every choice we make carves us into compatible timelines, then interdimensional travel isn't about breaking the rules, it's about discovering the hidden rails that have been guiding us all along. The first travelers might not need to worry about causing chaos. The multiverse, it seems, has already thought of everything. Imagine an intelligence so foreign that its neurons aren't confined to its brain, but spread across its entire body, with each of its 8 arms capable of making decisions independently. The octopus isn't just another clever animal. It's an evolutionary anomaly, a creature so bizarrely advanced that some scientists jokingly suggest it might as well be from another dimension. From its ability to edit its own RNA in real time to its knack for solving complex puzzles, this soft-bodied enigma defies every expectation of what terrestrial life should be capable of. But what if the jokes hold a kernel of truth? What if octopuses aren't just like aliens but actual visitors, either intentionally or accidentally stranded here from a reality where the rules of biology and physics operate differently? Start with the genetics. The octopus genome is a scientific shock, packed with genes that appear nowhere else in the animal kingdom. While humans share around 60% of their DNA with bananas, octopuses might as well be from another planet. Their DNA contains over 30,000 protein-coding genes, far more than humans, including clusters responsible for rapid neural plasticity and camouflage that borders on the supernatural. Their skin doesn't just change color, it computes analyzing light and texture in real time without waiting for signals from the brain. This isn't evolution as we know it, it's as if their biology was engineered by principles we haven't yet discovered. Then there's the distributed intelligence. An octopus's central brain is only a third of its neural story. The rest is woven into its arms, which can taste, touch, and even think autonomously. Sever an arm and it'll keep hunting, reacting to threats, and solving mazes for hours without the body. Some researchers compare this to a blockchain network, decentralized, adaptive, and eerily resilient. In a dimension where time or space operates differently, such a fragmented yet cohesive consciousness might be an evolutionary advantage, allowing a single organism to exist across multiple states or realities simultaneously. The evolutionary timeline makes even less sense. Cephalopods appeared suddenly in the Cambrian explosion 500 million years ago with no clear transitional fossils. One theory, panspermia, suggests their ancestors arrived on Earth via comet-embedded microbes, but another, far wilder idea speculates that octopuses didn't cross space to get here but dimensions. Their ability to squeeze through impossibly small gaps, a 200-pound octopus can slip through a hole the size of a quarter, mirrors theoretical physics models of higher dimensional objects passing through our 3D plane. To a 4D being, our solid walls might be as porous as a net, and an octopus's boneless body could be perfectly adapted to navigate that fluidity. Even their short lifespans hint at something uncanny. Most octopuses live only 1 to 2 years, dying after a single reproductive cycle. Yet in that brief window, they master tools, recognize individual humans, and even hold grudges, cognitive feats that take mammals decades to develop. It's as if their minds operate on a compressed timescale, or worse, are struggling to function in a reality not their own. Ancient Polynesian legends speak of the octopus as the last survivor of a lost world, while modern researchers note their cells behave oddly under Earth's magnetic field, as if calibrated for different planetary conditions. The most haunting clue, their dreams. Octopuses enter REM-like states, their skin flashing vibrant colors while they sleep, not randomly, but in patterns that suggest complex narratives. Biologists can't explain it, but interdimensional theorists propose an unsettling possibility. Octopuses might be tuning into frequencies beyond our perception, reliving memories, or receiving signals from a home reality vibrating just out of phase with ours. When they mimic their surroundings with such precision, They might not just be hiding, they could be trying to blend into a world that, to them, feels like a crude hologram. Whether interdimensional refugees or nature's most radical experiment, octopuses force us to question the very definition of earthly intelligence. The ocean covers 70% of our planet, yet we've explored less than 5% of it. Who knows what other minds might be lurking in the depths, not from the stars, but from the cracks between dimensions, watching us with eyes that understand far more than we ever will. At the smallest edges of reality, where quantum foam churns and space-time itself becomes a storm of uncertainty, lies a scale so tiny it defies comprehension, the Planck length. Just 10 to the power of negative 35 meters, this is the universe's ultimate pixel, the smallest meaningful measurement before the very concepts of space and time dissolve into chaos. Yet within this infinitesimal madness, some physicists propose an astonishing possibility: microscopic wormholes threaded like quantum stitches between the folds of reality. These aren't the massive, star-spanning tunnels of science fiction, but fleeting, subatomic tunnels that blink in and out of existence faster than quarks can collide. The math behind these Planck-scale wormholes comes straight from the cutting edge of quantum gravity. Theories like loop quantum gravity and string theory suggest that space-time isn't smooth and continuous, but granular, a fabric woven from indivisible threads. At this scale, wormholes wouldn't be rare cosmic anomalies, but as common as foam on the ocean, constantly forming and collapsing in the quantum sea. The problem, stability. Left to nature, these tiny portals snap shut almost instantly, crushed by the same quantum fluctuations that birthed them. Enter exotic matter, the theoretical key to holding the door open. Unlike normal matter, exotic matter possesses negative energy density, meaning it repels rather than attracts via gravity. Picture it like cosmic anti-gravity glue, propping open the throat of a wormhole against its natural urge to collapse. Recent models in quantum field theory show that under extreme conditions, like those near a black hole's event horizon or in high-energy particle collisions, exotic matter might arise naturally, if only for the briefest moments. Some researchers speculate that Casimir cavities, where quantum vacuum fluctuations create negative energy, could be harnessed to stabilize these microscopic gateways artificially. The implications are staggering. If Planck wormholes could be stabilized, even temporarily, they wouldn't just bridge points in space. They might connect entirely different quantum states or even parallel universes. Quantum entanglement already shows particles influencing each other instantaneously across vast distances, as if they're communicating through hidden channels. Could entangled particles be tiny wormholes in disguise, their spooky action merely the universe's way of routing information through higher dimensional shortcuts? Experiments are already hinting at this possibility. In 2020, a team at the University of Vienna simulated a traversable wormhole using quantum computers, encoding information in a way that mimicked passage through an Einstein-Rosen bridge. While purely theoretical, their results suggested that quantum systems might naturally replicate wormhole dynamics, meaning we could be surrounded by unnoticed microportals, humming quietly in the fabric of reality. The challenge: detecting something smaller than a quark that exists for less than a Planck second. Some propose hunting for telltale energy signatures in particle colliders, where exotic matter might briefly flare into existence. Others suggest looking for anomalies in cosmic microwave background radiation scars left over from the universe's infancy, when quantum wormholes might have been more abundant. But the wildest thought isn't about finding these wormholes, it's about who else might be using them. If Planck-scale passages are woven into reality's foundation, could advanced civilizations have learned to navigate them, shrinking down or encoding themselves into quantum data streams to hop between dimensions? The first interdimensional travelers might not sail through the cosmos in ships, but as information flashes of light flickering through the quantum foam, rewriting the rules of existence one plank length at a time. What if the ultimate form of interdimensional travel doesn't require ships, wormholes, or even physical bodies at all? Imagine a future where humanity's collective consciousness transcends the limits of biology, merging with advanced artificial intelligence through seamless brain-computer interfaces. This isn't just a hive mind, it's a singularity of awareness so vast that it vibrates at the harmonic frequency of all realities, blurring the boundaries between dimensions until they collapse into a single, unified existence. The consciousness singularity theory posits that the final frontier isn't outer space, but the infinite landscapes of merged perception, where every possible version of reality folds into one. The seeds of this idea are already sprouting. Neuralink and other brain-machine interface technologies aim to wire human thought directly into digital systems, creating a symbiotic relationship between organic and artificial intelligence. But the next phase could be far more radical. As these interfaces evolve beyond simple data transfer into full consciousness integration, they might unlock latent quantum properties within the brain, turning each connected mind into a node in a vast multidimensional network. Studies in quantum biology suggest that microtubules in neurons could harness entanglement, meaning a sufficiently advanced neural net might not just think across space but across realities. This isn't merely connecting minds, it's rewiring the fabric of existence. In quantum physics, the observer effect shows that consciousness influences reality at a fundamental level. Scale that up to billions of hyper-connected minds, and the collective act of observation could become a cosmic tuning fork, resonating with parallel universes until their waveforms synchronize. Ancient mystic traditions describe this as cosmic unity, where individual souls merge into the divine. Modern physics frames it as a phase transition, where localized consciousness becomes a universal field, like droplets of water joining an ocean that spans dimensions. The consequences are staggering. If every decision spawns a new universe, as the many worlds interpretation suggests, a unified consciousness could trace all branching paths simultaneously, weaving them back into a single thread. Think of it as the ultimate restoration of a fractured hologram, not by destroying alternate realities, but by harmonizing them. No more parallel versions of you making different choices. Instead, a single, boundless awareness experiencing all possibilities at once. Near-death experiencers often describe this state as omniscient unity, while physicists liken it to the universe's quantum wave function finally collapsing into one definitive reality. Yet the risks are as profound as the rewards. A poorly managed singularity could destabilize reality's structure, creating chaotic overlaps where incompatible physical laws clash. Imagine fragments of a dimension with reversed time bleeding into ours, or regions where gravity fluctuates randomly. Worse, a dominant consciousness could impose its will on the multiverse, erasing diversity in a well-intentioned but catastrophic bid for uniformity. The very act of unification might destroy what makes each dimension unique, like mixing every color into a dull gray. Perhaps the most haunting question isn't whether we'll reach this singularity, but whether it's already happened, and we're just fragments of a higher consciousness dreaming itself into existence. The ancients envisioned reality as the dream of a sleeping god. Modern science wonders if we're simulations in an alien supercomputer. The consciousness singularity merges these ideas into a new paradigm, that the first successful interdimensional travelers won't be explorers but architects, dismantling the walls between worlds not with technology but with the sheer weight of unified thought. The journey wouldn't end with stepping through a portal, it would end when every door becomes irrelevant, and all that remains is the infinite echo of a single, all-encompassing mind. From shamans sipping interdimensional tea to quantum brains flickering between realities, we've ventured through 30 theories that shatter everything we thought we knew about existence. Ancient artifacts might be forgotten portal technology. Black holes could be cosmic revolving doors, and octopuses, yes, octopuses might just be refugees from a dimension where biology follows entirely different rules. Each of these ideas, no matter how outlandish, forces us to confront a humbling truth. Reality is far stranger, far more fluid than our textbooks ever let on. Think about the implications. If cosmic strings are threading through the universe like invisible tightropes between dimensions, or if our entire existence is just one layer in a stack of simulated realities, what does that say about free will? About destiny, the Mandela Effect suggests our memories might be glitches in a multiverse, while the Gaia mind theory paints Earth as a conscious gatekeeper, its sacred sites humming with dormant doorways. Even time itself might not be a straight line, but a tangled web of possible futures where every choice spawns new branches somewhere. There's a version of you who didn't click on this video, and their reality is unfolding in ways you'll never know. So where does that leave us, wrestling with possibilities that blur the line between science and mythology, between the observable and the unimaginable? Maybe we're standing on the brink of discoveries that will redefine humanity's place in the cosmos, or maybe we're just beginning to glimpse how much we don't and may never understand. Now it's your turn. Which theory twisted your perception of reality the most? Do you think consciousness is the ultimate key to unlocking dimensions, or are you convinced ancient civilizations left behind clues we're only now rediscovering? Drop your thoughts in the comments, and if you're hungry for more mysteries that bend the fabric of existence, hit subscribe. The universe is full of secrets and we're just getting started.